Hello, so we shall be talking about Mlops on our project. So it's about interpretable machine learning techniques for predicting cryptocurrency fraud. That's our project. We're going to see how we apply Mlops. So we are two in the group. I'm Yasin Burhan and my fellow Modu Shedrick will be taking us about the other part. So this is our model. Our model, what does it do? So it mainly, these are just summary of the thing. We're going to share the code in our GitHub, which you're going to give the link and everything. So the code will be there. So I've summarized what the whole model does. So first of all, we're going to prepare the model, like we're going to get those data sets and prepare. Then we're going to train the model. 80% will be used for training, then 20% will be used for testing. Then after, our data sets has a lot of issues. So it has very many issues. So we are going to data pre-processing it, whereby we're going to be mainly dealing with those missing values, that part. Then after, we're going to deal with data pre-processing and scaling. We're going to be using Scalar. Yeah, just that. We're going to, after the data pre-processing class, this is the class we're going to use for this data pre-processing. So we're going to use standard scalar for standardizing the numerical values. Then after, we're going to train the logistic regression. We are going to be only using logistic regression model. After that, we shall integrate our mail flow. Then after, we shall serialize. So we've talked about this, training the model. We said 8% will be used for training, then 20% will be used for testing. This is how our code structure looks like. As you can see, the project after Ethereum, the crypto.py will be the code, our code for the model, crypto.py. Then the app.py is going to be for the Flask. We are going to see how we are going to integrate API endpoint. That will be the Flask. Our dataset is called transaction dataset.csv. So this will be our datasets. And the rest are just, this is the requirements. These are just testing. We're just used for testing. Yeah. Then this part is for the logistic. We just got a snippet of the logistic regression code. So as you can see, this is the code. We are going to just take the model logistic regression. We're going to iterate it 1,000 times. Then after that, we're going to use this DF train prep. Then the flag will be the target. We're going to use that target. Then we're going to, of course, see, we're going to check the train, the value for the train, the validation also for the testing, for training, validation, and testing. That's what we'll be using. Then after running the model, we're going to find out that the first value here, 0.863, will be for the trained value. Then the validation is going to be 0.59. Then the testing is going to be that 0.84. Then after that, finally, we shall have to dump our models as we can use it later. That will be that bit. So secondly, we use Git. This will be the link. This is the link. You can find the whole code in our GitHub. We also deployed the model using render. We use render as our deployment. So it will also be there on render. We deployed the thing. We also use the code, and that says everything will be there on GitHub. That will be, and this is how it appears on GitHub. So this is here. Yes, this is our GitHub. Now let me call my colleague to take us through the endpoint. Modi Shedrick, welcome, sir.
Greetings to you all. My name is Modi Shedrick, and I'm going to be taking you through I'm going to talk about the Flask API endpoint. The Flask API is basically a Python framework. It creates an endpoint, predict that can be used to send a JSON data for prediction. So basically, when a client sends their data in JSON format to predict the endpoint, the server uses this data to make their prediction about the data, and then it also uses logic regression model after pre-processing the data input, whatever, using the data prep class. And then, so after sending the request, I mean, this method is not allowed because basically it is a get method. When a client sends whatever a post, whatever a request, it is not allowed because it is a get whatever request. That's why it's not allowed. So basically, you for some you go back. Go back. Down, down, down. Down, go down. So this is our ML Flow dashboard. So basically, in this code, we use our the model we use this logistic, evaluate the model, and the evaluation part, we first train the model, and then you validate the score, and then whatever, and then we tested the model. So after training, after evaluating the model, the next thing we did was what? To log the metrics or whatever in the ML flow, and then after logging after logging the metrics, it takes us to a site. First, go back. Yeah. You go back. Go to whatever next line. So after logging our metrics, whatever, and then we came and ran the whatever to the site. Next slide. Next slide. So basically, after logging, first of all, we evaluated our models. After evaluating, in the evaluating process, we trained the models, and then we validated. After that, we logged the metrics. So after logging the metrics, whatever it ran on the server, and the server can be accessed via that link mmlflow.ui, which is on the server 127.0.0.1.5000. Next line. Next line. Next line. Next line. Next line. So basically, when you click on that server, it takes us to that to this our ML4 dashboard. This is where our whatever's are found, our code and the things we did earlier. So basically, that was the small thing I wanted to discuss about in this presentation.
Okay, that's all we had. We said we use render also for deploying the model and everything. So we've run the ML flow, and we've talked. My fellow has talked about it. Then we also use Flask API. So we created the Flask endpoint using Python Flask, and that's all for the whole